How many solutions do each of the following equations have? Given the quadratic equation in standard form, ax squared plus bx plus c equals 0, we can use the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The b squared minus 4ac, which is the radicand, is called the discriminant. This is because it discriminates between three possible scenarios for the solutions to a quadratic equation. There could be either two real solutions. This corresponds to if the discriminant, b squared minus 4ac, is greater than 0. This means that the plus or minus the square root of b squared minus 4ac will give different results for adding or subtracting. The graph then would intersect the x-axis at 2 points. We could also have one real solution. This would represent b squared minus 4ac being equal to 0. In this case, the plus or minus square root of b squared minus 4ac, which would be plus or minus 0, would give the same result if you add 0 or subtract 0. In this case, the graph would intersect the x-axis at only 1 point. Finally, there could be no real solution. In this case, b squared minus 4ac is less than 0. In this case, taking the square root of b squared minus 4ac would correspond to the square root of a negative, which is undefined. In this case, the graph does not intersect the x-axis. Looking at the first question here, 3x squared equals 6x minus 5, we first have to convert it to standard form. To do this, I'll subtract 6x and add 5 to both sides. We then have a equals 3, b equals negative 6, and c equals 5. Substituting this in simply into the discriminant, we do not have to solve for x here. We get negative 6 squared minus 4 times 3 times 5. This gives a result of negative 24. Since the discriminant is negative, in this case, there is no solution. For the second question, 4x squared equals 12x minus 9. Again, first converting to standard form, and then substituting a, b, and c into the discriminant. Here we have negative 12 all squared minus 4 times 9. This gives a result of 0. Since the discriminant equals 0, in this case, there will be one solution. And the last question, 2x squared equals 3x plus 2. Again, changing to standard form, and then substituting once again into the discriminant. Negative 3 all squared minus 4 times 2 times negative 2. Here we get a result of 25. Since the discriminant in this case is positive, we will have two solutions.